Recursion permits the definition of a single process as the solution of a single equation. The technique is easily generalized to the solution of sets of simultaneous equations and more than one unknown. For this to work properly, all the right-hand side must be guarded and each unknown process must appear exactly once on the left-hand side of one of the equations. Example, a drinks dispenser has two buttons labeled orange and lemon. The actions of pressing the two buttons are set orange and set lemon. So the actions of dispensing a drink are orange and lemon. The choice of drink that will next be dispensed is made by pressing the corresponding button. Before any button is pressed, no drink will be dispensed. Here are the equations defining the alphabet and behavior of the process DD. That is the drink dispenser. The definition uses two auxiliary definitions of O and L, which are mutually recursive. So alpha drink dispenser would be its alphabet, which is same as the alphabet for orange and alphabet for lemon. So in this way, we define the alphabet and the process description of the drink dispenser. Informally, after the first event, which must be a setting event, the dispenser is in one of the two states, orange or L. In each state, it may serve the appropriate drink or be set into the other state. Pressing the button for the same state is allowed but has no effect. By using indexed variables, it is possible to specify infinite sets of equations. Another example, an object starts on the ground and may move up. At any time thereafter, it may move up and down, except that when on the ground, it cannot move any further down. But when it is on the ground, it may move around. Let n range over the natural numbers. For each n, introduce the indexed name Ctn to describe the behavior of the object when it is in n moves off the ground. Its initial behavior is defined as Ct0 up, then Ct1, choice around, then Ct0, and the remaining infinite set of equations consists of Ctn plus 1, where n ranges over the natural numbers. An ordinary inductive definition is one whose validity depends on the fact that the right-hand side of each equation uses only indices less than that of the left-hand side. Here Ctn plus 1 is defined in terms of Ctn plus 2, and so this can be regarded only as an infinite set of mutually recursive definitions, whose validity depends on the fact that the right-hand side of each equation is guarded. I'll discuss about the dining philosopher's problem from concurrency. It surrounds around the five philosophers and five philosophers placed around a table, and there are also forks, five forks placed alternatively, and so the problem is, in ancient times, a wealthy philanthropist endowed to college to accommodate five eminent philosophers. Each philosopher had a room in which he could engage in his professional activity of thinking. There was also a common dining room furnished with a circular table surrounded by five chairs, each labeled by the name of the philosopher who was to sit in it. The names of the philosophers were given, and they were disposed in this order, anti-clockwise around the table. To the left of each philosopher, there was laid a golden fork, and in the center stood a large bowl of spaghetti, which was constantly replenished. A philosopher was expected to spend most of his time thinking, but when he felt hungry, he went to the dining room, sat down in his own chair, picked up his own fork on his left, it into the spaghetti. But such is the tangled nature of spaghetti that a second fork is required to carry it to the mouth. The philosopher therefore had also to pick up the fork on his right. When finished, he would put down both his forks, get up from his chair, and continue thinking. Of course, a fork can be used by only one philosopher at a time. If the other philosopher wants it, he just has to wait until the fork is available again. So we give alphabets for the philosopher and for the fork. And for the behavior, apart from and we define the behavior apart from thinking and eating, which we have chosen to ignore. The life of each philosopher is described as the repetition of a cycle of 6 events. The role of a fork is a simple one. It is repeatedly picked up and put down by one of its adjacent philosophers. The behavior of the whole college is in the concurrent combination of the behavior of each of these components. An interesting variation of this story allows the philosophers to pick up the two forks in either order or put them down in either order. Consider the behavior of each philosopher's hand separately. Each hand is capable of picking up the relevant fork. Both hands are needed for sitting down and getting up. Synchronization of sitting down and getting up by both left and right ensures that no fork can be raised except when the relevant philosopher is seated. Apart from this, operations on the two forks are arbitrarily interleaved.